A new X-ray catalog of 2 million sources shows galaxy cluster outskirts hotter and cleaner than models predicted. This is Fascinating Frontiers, episode 160. The E-Rosetta telescope surveyed half the sky and produced a catalog containing nearly 2 million X-ray sources, approximately double the size of its first release. A team at Bonn examined the faintest outer regions of a massive galaxy cluster, where fresh gas continues to arrive along intergalactic filaments. Measurements showed this gas to be hotter, denser, and poorer in heavy elements than current hydrodynamic models predicted. No earlier observation had reached this low surface brightness regime. The complete catalog is now publicly available for community analysis. The E-Rosetta catalog's outer cluster measurement shows gas that is both hotter and less enriched than simulations predicted. The discrepancy appears only at the lowest surface brightness levels now reachable for the first time. This region is where fresh intergalactic material continues to flow in along cosmic filaments. The finding suggests current models miss key physics governing how clusters assemble. Follow-up X-ray and Sunyaev-Zeldovich observations will test whether the pattern holds across more systems. Imagine a filament of gas stretching between two galaxy clusters that spans a distance greater than the drive from New York to Chicago, yet contains less mass per cubic meter than the air inside a party balloon at cruising altitude. That is the physical scale of the material E-Rosetta measured for the first time in its second data release. Fresh gas falling inward along these filaments should compress and heat according to standard hydrodynamic prescriptions, yet the new observations record temperatures several million degrees higher and heavy element abundances several times lower than any simulation currently produces. The telescope reached this regime by stacking thousands of faint photons collected across half the sky, pushing the surface brightness limit well below previous X-ray surveys. No one yet knows whether the excess heat originates from undetected shocks, from energy injected by earlier generations of galaxies, or from mixing processes that transport metals less efficiently than models assume. The single unanswered question is whether every massive cluster will display the same mismatch once its outskirts are examined at this depth. New catalogs and long baseline observations continue to refine our picture of how the universe builds and recycles its largest structures. From the unexpected physics at cluster edges, we turn to a mission that also pushes observational boundaries but on a commercial timeline. Virgin Galactic announced it will not begin commercial flights of its new suborbital spaceplane until early 2027. The delay of several months follows continued vehicle testing and certification efforts. No specific technical barriers were identified in the update. The revised schedule shifts the start from the previously targeted late 2026 window. Observers are monitoring the next series of test flights to assess whether the new timeline remains on track. While one operator adjusts its schedule, another space-based observatory is already delivering on its timeline. The Meteosat third-generation imager on MTG-I-1 recorded the moon's dark shadow crossing Greenland, Iceland, northeastern Portugal, and Spain. Images were acquired from geostationary orbit at 36,000 kilometers altitude between 8:26 p.m. and 8:34 p.m. Central European Summertime on 12th August. The same dataset also captured the partial eclipse visible from northern Canada, the Nordic countries, and western Africa as far south as Sierra Leone and Liberia. MTG-I-2, the third satellite in the series, is scheduled for launch on August 27, 2026, aboard an Ariane 6 from French Guiana. The mission continues building toward full operational coverage of Europe and northern Africa. From operational satellites watching Earth, we move to readers who traveled to experience the eclipse directly. A group of roughly 50 astronomy readers observed 1 minute and 30 seconds of totality from Madrid on the evening of 12 August. The travelers had spent the preceding week exploring the region before the eclipse. Participants described the sudden darkness and the visible solar corona as mesmerizing. The magazine published first-hand accounts along with images captured during the event. Planning is already underway for additional reader expeditions to future eclipses. Personal eclipse stories lead naturally to another long-term observational effort now bearing fruit. A Polish-German collaboration tracked a single blazar continuously using 2 orbiting observatories over nearly 20 years. Two observations from 2012 revealed a spectral feature that no existing model had predicted. Conventional blazar campaigns typically span only a few days and focus on narrow energy bands. The extended baseline uncovered variability patterns that shorter campaigns had missed. Researchers are now examining other multi-year data sets for comparable unexpected features. Long baseline data continue to surprise us. Next, we look at how the earliest supernovae shaped the ingredients for planets. University of Portsmouth researchers calculate that the first supernovae enriched the cosmos with rocky planet building blocks only 100 million years after the Big Bang. This enrichment occurred well before the first galaxies assembled. The models follow how supernova ejecta cooled and condensed into dust grains. Those grains later supplied the raw material for terrestrial planets. Next steps include searching for the predicted dust signatures within the oldest known galaxies. From the earliest building blocks, we turn to a dying star whose material is being recycled right now. Astronomers obtained images of a dying star whose ejected fragments are being broken apart and mixed into the surrounding interstellar medium. The observations capture the stripping and absorption process at a level of detail not previously achieved. Data reveal how raw materials from stellar death re-enter the galactic reservoir for future star formation. The system lies thousands of light years away, yet displays clear chemical signatures of ongoing dispersal. Follow-up spectroscopy is planned to map the spatial distribution of the dispersed elements. Material cycling through galaxies brings us to a proposal that would study planets forming from that material. A Shanghai-led team has proposed flying 900 1-meter telescopes in coordinated formation. The array would observe the same planetary transit simultaneously to reach the 1 part in a million signal required for atmospheric characterization. An Earth analog planet transits its star only once per year, making each event irreplaceable. The distributed design avoids the engineering challenge of a single, extremely large space mirror. Engineering studies are now assessing formation flying precision requirements. Ambitious telescope arrays point to another ambitious goal, using the Moon itself as a resource base. Commercial teams are using NASA lunar datasets to design systems that would allow sustained operations on the Moon. The datasets include surface composition maps, radiation measurements, and resource distribution information. Companies intend to process local regolith for construction materials and life support consumables. The approach supports broader objectives for long-term human presence beyond low Earth orbit. Additional studies will evaluate how directly the existing datasets translate into hardware specifications. From planning future lunar infrastructure, we shift to how the human body itself fares in space. Human heart muscle cells grown under microgravity conditions on the International Space Station maintained normal contraction strength. The result stands in contrast to the documented weakening of bone and skeletal muscle during spaceflight. Experiments relied on specialized culture systems designed for the station's environment. The finding suggests cardiac muscle may respond differently to the absence of gravity loading than other tissues. Longer duration studies are planned to determine whether extended missions produce measurable changes. From human physiology in orbit, we look at how Earth itself appears from space during another natural event. A deep partial lunar eclipse will occur on 27 to 28 August 2026. Observers across much of the Americas and Europe will see the Moon pass through Earth's shadow. The event marks the final lunar eclipse before a multi-year observational gap. Timing predictions and viewing guidance are already posted by the magazine. Updated weather forecasts will be issued closer to the date. From upcoming eclipses visible from Earth, we close with images already capturing recent ones. Today's astronomy picture of the day presents an image of the 12th August total solar eclipse as seen from Spain. The photograph captures the solar corona and the darkened landscape during totality. A brief explanation written by a professional astronomer accompanies the image. Archives of prior eclipse APODs are linked for direct comparison. The feature remains available on the NASA site. Keep an eye on the MTG-I2 launch scheduled for August 27, 2026, as it moves the European Weather Satellite series toward full operational coverage. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. This show comes to you from the NARA network. If you want another sharp daily briefing, Unintended Consequences has you covered. True stories of good intentions that backfired. All our shows are free at naranetwork.com. New to the network? naranetwork.com Start Here picks the right daily briefing for you in about 2 minutes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.